Alright, it's either good news or it's bad news if you are lazy. There are 4 proofs. How many theorems are there? 9. All of them do have proofs, and they are all in your textbook. Starting from page 212, they put them all together there. Now guys, when you are studying and you want to use the proof that they give you, that's fine. Obviously mine is always better. Okay, so if I give you a proof, I want you to write it down because it will help you. This is parrot work. You either know it or you don't know it. But hopefully I don't teach it like a parrot. Hopefully you can understand what it's about so that you can understand how the proof works. So that you don't have to go sit there and say, A is equal to CD, A is equal to CD, I can't remember it up. Because it makes no sense if it's such abstract things. Now the proofs are the following. I want to prove theorem 1, theorem 2, then it's going to be theorem 5 and theorem 9 as well. Okay, those are the 4 proofs. In an exam, this one coming in June, I'm going to ask you one. Not maybe. Definitely. One of the 4 will be asked, 5, 6 marks. That means it's 6% of paper 1. I'm gonna. I have to. It's rules. Okay. So if I ask you, guys, here's my sketch. Prove the theorem that states that the line from the center is perpendicular to the chord. Then there's a whole method. I'm going to teach you. You know this now. When you go home, you must know you're going to do it with congruency. What? Congruency? Because I'm teaching you now. In the theorems, and only in the theorems, you will always have a construction. I was telling you in the sums, please don't do constructions, don't add lines. Only in theorems, you always will have a construction. So if I'm talking about congruent triangles, can you imagine it's going to be these two?
Yes.
So your first thing you're writing is construction. You draw AO and OC, or however you want to state that, but tell them. Usually metric paper, as long as the construction is on the sketch, they give you that mark. But let's be proper. I constructed that. Now the theorem is going to be in those 2 triangles, AOB, and then triangle what? I can't just name it the way I want to. If I call this one AOB, how did congruency work? If this is AOB, you've got to name the other one COB in the same order that they are equal to each other. COB. What are equal? Do you remember in grade 9 when you were taught congruency? That's the way you did it. And there's 4 reasons. We talked about them yesterday or the day before. 4 reasons. Side, 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 angle, side, angle, angle, side. And then in a 90-degree triangle, the right angle, hypotenuse side, and another side. What have I got here that's equal? Please don't tell me that the angle is 90. That's the theorem I'm trying to prove. Are you with me? You know that we're getting there, but you can't say now it's 90 and that's why it's 90. You're trying to prove it's 90. So you don't know it yet. You know what? There's a common side. Because it's common. Alright? And what else? AO and CO, why? Because they're both radii. Now listen carefully. If I say prove that a line from the center of the circle perpendicular to the chord will be bisected, line from the center of the circle to the chord, then the chord will be dissected, then I have been given, I changed my mind just now because there's actually 2 theorems I'll show you. If they give you that it's perpendicular, you want to prove that it's bisected. So you know then, like I said, I changed my mind, that it's been given that it's 90. So that would be your last thing. That B1 and B2 are both 90 because it's been given perpendicular. What are you trying to prove? That it will bisect. So you're trying to prove that AB is equal to BC. But the method that I'm always going to write here on the side in a little bubble, the method is congruency. This will not change. If you wanted to put number number 3 at number 1 and number 3. That's not what I'm talking about. But this will not change. The reason then for AOB being congruent to COB is look at it. It's the 90-degree angle. It's the hypotenuse side and another side. It is two sides and an angle, but it's not two sides and the included angle. So you can't say side angle, side. And it won't change in this proof. So in other words, the hypotenuse side, the right angle, and another side. However you were taught. Then, out of that, I will always say from congruency. Are you with me, guys? You will never prove congruency unless you win grade 9 and we say prove congruency. From congruency, we're finding something, namely that AB is equal to BC. Done. 5 marks. So it's probably for construction. 1, 2, 3. How many have I got here? 6 marks. With me. You can't say construction and not construct. Are you with me? How do I know then what's going on? And kids do that. They know this off by heart in their brains. Then I give you a sketch in the exam and I say X, Y, Z, and oh no. And everything's done. Please, I want you to understand it, not go and learn it like a parent. Are you with me? All right. I think, let me do the converse first before I go to theorem 2. We're going to do that exact same thing, so no problem. If I do the converse of theorem 1, if I ask you then to prove to me what? Prove that the line from the center of a circle to the center or midpoint of a chord will be perpendicular. Do you see the difference? Because that's the wording difference that you must know when you are using those theorems. So then, in other words, my sketch will stay the same. I'll still call it OA, B, C. But now what's been given?
The center.
Prove that the line from the center to the midpoint, so this has been given the midpoint, will be, so I'm trying to prove that B1 and B2 are both 90, or just one of them is fine, no problem. That's what I'm trying to prove. How do you guess we're going to do it? Also with? So we need?
Construction.
So you get it right. Construction, AO and OC. And you're again going to say in triangle, ABO, let me mix it up. And then if I say ABO, it's going to be CBO. I'm going to have 3 things equal to each other. Tell me. AO and OC are straight line. And? Okay, I'm sorry, I've written it already. Common. And AB is equal to BCY. Because it's given. So my reason for triangles being congruent would be side by side, side. What do you get from congruency?
That
That B1 and B2 are both 90. Is that actually everything? I know that they're equal, but they're both 90 because it's a straight line. So there's actually 2 reasons. They're equal, but it's a straight line, so both of them has to be 90 to make up what? 80. And that's the end of theorem 1.